Alright, cool. A medium, 7/50th. Visit array positions to maximize score. You're given a 0 index integer array nums and a positive integer x. You are initially at position 0 in the array and you can visit other positions according to the following rules. If you're currently in position I, then you can move to any position j such that j is greater than I. For each position I that you visit, you get a score of nums I. If you move from a position I to j and the parities of nums I and j differ, then you lose the score. Interesting. Return the maximum total score you can get. Note that initially you have nums 0 points. What is x? Okay. Interesting. So you're given a 0 index array of nums and a positive integer x. X is the score you lose if you jump to number of same parity. You're initially at position 0 in the array and you can visit other positions. Okay. Rules. You can only move forward in the array. Each that you visit gives you a score. I'm pretty sure parities, they just mean like it needs to be even, or odd. So you lose x if you visit an I that has the same parity as in. No, if it's different. So if you move from like a odd to even, you lose x. What's the constraints? 10 to the 5, 10 to the 6. So there's a penalty if you change parities. Add to j and the parities and nums differ, then you lose a score of x. Return the maximum total score you can get. This is kind of interesting. So we can visit the following positions in the array: 0, 2, 3, 0, 2, 3, and 4. Man, is this like a DP question? Or greedy? Maybe we can work backwards. Maybe we can work backwards from the array. Because we know if we get to this position, what's the max? 2. What if we work from this position? 9. We can either collect 9 or or take 9 minus x, or we can either, what's the best we can get to 9? We can either, it could be 9 or max of 9 minus x, because the parities change, plus 2. So we can either just stay, or we can do that. What if we're looking at 1? If we're looking at 1, we can pretty much make that same decision from here. We could jump to 9, we could jump to 2, and then we could just kind of keep making that same, it would be like an O of n squared. What if we're at 1? What's the maximum we can get? Max is we can jump to 9 or get the best result. Or we could jump to 2 and get the best result. We do I don't know if we could do a, what if we just need to keep track of like the last number, or we just need to know that if this is odd, I probably want to jump to the next odd. Okay, if it's odd, okay, what's the best result? What if I know the best result here, which is, wait, I can just, yeah, is this like some DP where you can just choose? Because it affects our decision if we decide to, oh, okay, we have 3 decisions here. We can choose 9 and then that's it. Okay, let's think about this from scratch. So we can if we only have one element, we have one number. So the max you can get is 2. What if I have 9 and 2? Well, the max is either I take 9, and would I connect myself with other odds? I think it would make sense to connect myself with other odds. No, that would That Nardo, that solution you're saying would be exponential. So what we do is maybe I think it makes sense that take same. Could we reduce it to take same parity or take other? What if we take same parity? Maybe find the max times you can switch since you can only move forward. Well, we want to minimize the times we switch, right? Because every time we switch, it adds up. So, but if we're at odd, it doesn't make sense to not just take all the other odds at least. So if there was so if there's one, it just makes sense to just you can pretty much collect here for sure. What if we're at one and then there's like 100? Well, actually, there's only two modes. So there's two. Okay, if x equals to 5, right? So pretty much if we're changing parities, we can get -3 here, -2, 1, -4. Wait, let's see. So this is the original array. So we can get -3 here if we're transitioning. Here we can get -2. Here we can get 1. This one, it makes sense to kind of go here regardless. 1, -4. This one we get 4, -3. So if I'm at 2, maybe I calculate what's my maximum if I come here from an even. If I come here from an even, then I'll do -2. So this is if I come here from an even, maybe I'll come here from an odd. So what about if you're even odd, you add those up to total your current max and switch if it beats your current max starting from the end. I don't know exactly understand what you're saying. Wait, let me think about this for a bit. It might be DP. It might just be. Yeah, I do on calls. I've done a lot of on call. Yeah, I can't solve this question. So 2, the result is 2. What if it's 9? We could either take 9, 7 p.m. That's crazy. How long did it take to How long did it take to resolve it? Wait, 9 plus, so we can either take 9, so we can either take this or don't. If we take this, damn, by 7 p.m. you sleep early, huh? So we can either take and don't take. Try decision tree. Yeah, either we take this, that'll be a 9, and then and then we stop, or we take 9 and then we do. Since this is different, it'll actually give us -3. So there's really no point in taking 9, because that's going to give us -3. I could see a O of n squared solution. What if we have 1? 1, we can take this. Once we take that, the max is 9. There's 1. Since the same parity, we're good. But what if it's a different parity? Do we just need to care about the next parity? So 9 and then 2. I think we just need to care about the next parity. So yeah, we just need to care about the next one, because if there was another 4, do we care about us jumping to that 4? Probably not, because if we jump to the 2, we would get to that 2 and the 4 without losing anything. So I think we just need to keep track. Last odd. Last even. And then our result is and we jump from the back, is the current plus last odd current plus last even. And then like depending on if we're changing, maybe minus x. Okay, chat, it's pretty much this. It's pretty much this. And then we just work from the back. Because we know we 6. If we add it, if it's an even, it's an even. Then we pretty much just find the last even. And whatever maximum that has, we're good. So we're going to store some result array. It's going to be like some DP array. And on this DP array, we're going to have the max at each index is the maximum that we can get. What am I going to do? I'm going to do system design. I'll do machine learning. I'll vibe code in front of everyone. There's unlimited things to do, man. What do you mean? I'll do code forces. There's a lot. What's the max of 2? For num. For I in range length of nums minus 2 minus 1 minus 1. Print. Man, this one took me way longer than I needed to. Print. Last odd equals if nums at -1 mod 2 equals 0. Then we'll do even 0, 1, 2, 3, 4, 5. So we just need to compare it with the last even. If I can answer some questions after. Let me grind this out. Why do you want to break into DevOps specifically? Why not keep it more general, like software engineering? Equals current nums I. If it's even. So what? So we is even if easy. Okay. What we're gonna do is dp of I or stand even. Switching equals if it's even, extend, switch to odd, extend, odd, or switch to even. dp of I. So if we want to extend, if last even equals exists. I mean, I feel like DevOps is enough. I see. What I haven't really looked into DevOps roles. Like what do they usually do these days? Man, why is this question cooking me? I haven't looked into DevOps roles in a long time. I don't know even know what they're doing these days. I don't see that many DevOps engineers and DevOps engineering roles. In 2021 there used to be more, so I feel like that one is way less these days. Current current plus Yeah, because this is switch. Because we're trying to maximize. Switch to list indices. Something like that. Print no print DP. So if it's even, we can, what's the max? We can either extend with another even. So we'll take the current number plus the last time it was even, or take the current number plus the last time it was odd minus x. If it's odd, we can take the last time it was even, or we can take the last time it was odd and just keep extending. So it's like, or if this is even case. So with the odd case, if it's the odd case, if we have an even, we have to take the penalty to switch to that one. Why this not work? Holy chat, I think we figured it out with our last brain cell. Let's go. We figured it out with our last brain cell. You can see how slow my brain was moving. All right. That was 750 questions. Holy crap. Becca, you thought they got us, huh? Let's go. will never fold. Holy crap. Okay, how did people actually solve this? Okay, they kind of solved it the same way. I don't even know. They want to see me fold on my last brain cell. All right, thanks everyone for tuning in.